Instrumentation. What is it? Instrumentation? Instrumentation? What is instrumentation? Instrument. Instrumentation is a tool used for measuring, and it may or may not be a part of a system. Utilize electricity, utilize a sensor, utilize signal conditioning, utilize a data display, HMI or human machine interface, GUI or graphical user interface. Utilize communication protocols, utilize a controller. And finally, some people include actuators in their instrumentation system. That would mean the output of a control system. Don't worry if you don't know what all these are or how they relate to instrumentation, because we will be visiting them in future classes. So now we're going to talk about the components of an instrumentation system. And I've drawn a general system. This is based off of the system in your instrumentation textbook. So first we have a measure end, and that would be any physical process or quantity or characteristic, such as light, sound, volume, flow rate, those types of things. And that the act of measuring creates a signal. And at first it's unconditioned. We want to condition that signal because it's very, most likely a very weak signal, maybe a small resistance change or a very small voltage. So we condition that signal, we send it through an amplifier, and then we convert it from analog to digital. There are other types of signal conditioning processes that we won't get into much in this class, maybe a little bit more. So once the signal is conditioned, becomes a conditioned signal. Then we send it to a few different places depending on what type of system we have set up. We can send it to the controller. That's where we actually process the signal and make decisions based on that signal, and then actuate specific outputs based on that signal and decisions made. Or we can send it to a user interface or display. All right, so now that we know the system, let's look at an example. Let's look at an iPhone, the ambient light sensor on an iPhone. So when the lights turn off in the room, the ambient light sensor in the room senses a change in resistance. So that's how the sensor is actually working. The resistance changes. That resistance is amplified and converted from an analog to a digital signal. Then it's output as a digital voltage. So the digital voltage is then read by the controller, and then the controller makes the decision to dim the screen's brightness. And there we have it. That's how a component instrumentation system works. Different parts of this may vary depending on the system, but this is a basic system. Many systems we use today in our world involve instrumentation. Instrumentation helps us to automate systems. Nature is the ultimate automator of systems. Nature automates every one of its systems without instrumentation. Or perhaps we could say it uses its own biological instrumentation. Another argument for another time. For example, water filtration is done in nature automatically. When it rains, the water falls to the ground, slowly falls through the gravel in the ground, makes it to the water table as filtered water. Humans, on the other hand, aren't that patient. We want filtered water now. So we create our own filtration systems using automated processes, which of course we need instrumentation for. The systems are what we want to focus on now. What are some automated systems that require instrumentation? Take a pause and in your notes, write down at least 3 systems that you can think of that are automated or use instrumentation. So now that you've written your list down, here is a very short list of other systems that use automation. The automobile, which we'll talk a little bit more about in a minute. HVAC system, which stands for heating, ventilation, and air conditioning. A power plant, and an iPhone. All of these are systems which are automated using instrumentation. Now we're going to talk about the automobile, specifically the internal combustion engine. So an automobile uses an internal combustion engine, which is an automated system. There are 3 requirements that we need for combustion in an ICE or internal combustion engine. That's fuel, oxygen, and heat. So the way that it works, I've drawn out an example of a cylinder here. We have a piston which moves up and down. We have an intake valve, a spark plug, and an exhaust valve. When the intake valve opens, the fuel and air enter the cylinder. Then the spark plug ignites, giving us the heat we need. So these are very important elements of the process that we're trying to control here. So what types of instrumentation do you think we would use to measure fuel, oxygen, and heat? Take a few minutes and write it down in your notes. I hope you came up with a good list. Here's my list of a few necessities. To measure air, we have a MAF, mass airflow sensor, or sometimes both, MAP sensor, a manifold absolute pressure sensor. For fuel, we have the level in the tank, the pressure in the fuel rail, and sometimes we measure injector feedback as well, but not always. For heat, sometimes we measure ignition feedback, but that's a newer technology, so it's definitely not implemented in all vehicles yet. All right, so these are some of the absolute necessities we need to control the combustion process. However, we are humans and we are engineers, and we like to make things better. So I want you to take a few minutes in your notes and write down some more sensors that we could use to improve the combustion process. Think about things we want to improve in our vehicles. Things like fuel efficiency, more torque, higher horsepower, better environmental controls. So what are some other sensors we might use to make this process even better? Let's see what you come up with. All right, what ideas did you come up with? Were they good? Here are some of my ideas. We could take the temperature of the coolant, the cylinder, make sure that we're running at maximum efficiency. We could test the exhaust efficiency by checking if there's any unburned fuel in there, or checking the amount of oxygen content. We could measure the camshaft and the crankshaft rotation. We want to make sure that they don't get out of sync, and if they are, then we know that that's a bad situation, so we need to shut that engine down. We also could measure the time. We know that the crankshaft and the camshafts need to rotate at specific intervals. We could vary the valve timing by changing the rotation of the camshafts. So there's something called variable valve timing, but we can't do that unless we know the speed at which the cams are rotating in the first place. So over the time of the internal combustion engine, we engineers have continuously come up with different ideas for how to measure the different measurands within the engine and come up with better ways to make it more efficient. Thanks for learning about the automation in the internal combustion engine. So these instruments create signals which are sent to the engine control unit. That is the controller of this system, and it makes decisions based on the signals on how to control the system. We'll learn more about controllers in another class. But for now, all we want to know is that this is an automated system and it uses instruments to control its processes. And we can add more instruments to increase the efficiency of this system. Thank you for learning about instrumentation.